Good morning, ladies and gentlemen. After two honors, good to have everybody here today. Missing a couple of our good people, but we're going to try to get by. Yesterday we left it with using this second identity. We had this list of identities here, and what we did is we have this thing right here, 89, which we can rewrite as quantity 90 minus 1 squared. And using this identity here, we can rewrite this 89 squared as 90 squared minus 2 times, and this is going to be x equals 90, y equals 1, right? So minus 2 times 90 times 1, which is y, plus y squared. And so we have here is we have 8100 minus, that's going to be 180 plus 1, and that's going to be equal to, is it 7921? Is that right? And then if we test that in our calculator, and we can test these at the end, 89 squared, so we get this, right? So that's right, isn't it? Okay, what I want you to do is to do number 19 similarly, but what I want you to do is I want you to let x equals 50 and y equals 3, and use the same type of identity. Can you do that? Then I'm going to call on somebody in
the wheel
in another minute. Lexi's just sitting there. She's already done it.
Lexi done.
How far have you worked ahead on these, Lexi? Just this one? Okay. All right.
I thought it was 7,921.
Pardon me?
Huh?
Oh, 21 is what you're saying. Yeah. Yeah. Thank you, Marcus, for fixed that. Thank you, Marcus, for fixing that answer. I always appreciate Marcus here. He's really good, even if he gives his worksheet a hard time.
Okay, so now I got the right answer.
There we go. Good job, Marcus.
That's right. I used to walk around.
I still didn't want to.
Oh, you know what?
You know what? I'm just I can read it.
That is so good.
You gotta show the camera.
I don't know how you got the right answer, but I got the right answer.
Oh, it's plus one, plus one.
I just want to do this. I don't know. Well, not really.
Yeah,
I bet we are like, well, there we are. We graduated high school and everything. We are.
Okay, here we go. All right, let's see who we have here today. Right off the bat.
Yes, please.
Yay.
Yay.
All right, Shy, what's up, Shy?
Hi. Okay. So I did. What do you want me to do? The right side or left side? Because the left side is like you said, 50 minus 3 power 2. The right side is 50 power 2.
Like this? Okay.
And 50 to the power 2 minus 2 parentheses 50 parentheses 3 plus 3 to the power 2. And 50 squared is 2,500
Smart.
minus 300 plus 9. And then you combine them, it's 2,200.
Like this?
Yes.
Is that it? Let's go ahead. Got to make sure the calculator, 47. Checked out the calculator. Yep, that's it. All right. Very good, very good. Thank you for that. We are going to now go to the next set, which is using yet another identity. And it's going to be the difference of squares identity. And I'll write that out for you. And here's the difference of squares identity. Let me see if I can make this a little bigger. Okay, difference of squares identity is this one here. X squared minus y squared equals x plus y times quantity x minus y. All right? Does that make sense to you?
Yes.
Yeah, that does.
Do you see how to apply it here?
Sure. Yeah.
Okay, what's x going to be and what's y going to be?
54 and 38.
Okay. No.
It's not.
No, what's x and y going to be? What do you got to do for x?
Okay, let's see.
Well,
What's x going to be?
5.
No.
54?
No.
It's gonna be
is it the square root?
30.
Oh.
13. Oh, it's gonna be 50, right?
No, it's gonna be the square root of 54.
That's gonna be 60 or 50.
Okay, guys. I will show you what it is. It's not really super apparent. It took me a minute to figure it out too. What x is going to be, it's going to be the average of these two numbers. Okay? So x is equal to 54 plus 38 divided by 2. And that's going to be, what, 92 divided by 2?
Exactly right.
So that's going to be 46.
All right.
Okay, now, if x is 46, what's y going to be? Y is going to be,
46.
no, y is going to be the difference between 46 and 54, or the difference between 38 and 40. What's the difference between those two?
8.
8.
Good job, Mark.
And so what we have is this is going to be end up being y x plus y, right? Which is 46 plus 8. And this one is going to be x minus y, or 46 minus 8. Does that make sense? So let's go ahead and work the identity. So now we can write this out. This is what we have. And we want to make it like this. So we can rewrite 54 times 38 as x squared minus y squared. Now in this one here, it's going to be, because the numbers are not, it's not as easy to see what this would be in your head, but we can write this one as what? We can write this one, we can do another xy thing and write this as x squared plus 2x y plus y squared, and then we can subtract from this 8 squared here. You see that? So you see what we did with this? We used our earlier identity to break down this 46. So now we can put it all together and get, what is this going to be, 1600? And then 2 times 40 times 6. What's 2 times 40?
80.
80. And 80 times 6 is
400.
480. plus 36 minus 64. And that should be it. So that's going to be, what is that going to be, 2080
I'm thinking about.
minus 36,
Thinking about 2008.
2080, and then these combined would be, it's hard to, is that 28? Is that minus 28?
22.
Minus 22?
Guess, yeah.
Should be minus 20.
Hold on.
Well, that's, I give up.
32. 32.
The difference between,
32.
okay, look at this.
Mark, what is 32 by 64?
I'll ask Mr. G. Brandon wants to know how you got 8.
How I got what?
How'd you get 28?
28.
It's negative
Okay,
and 30 if that's 16. It's 28, negative 28.
Negative 28.
well, so negative 28, yeah. So that'll be what, 2052? Is that right?
2052.
2052. I'm going to handle Braden's question in a minute, though. So 54 times 38, let's hope that's right. 54 times 38,
Yeah.
be right. Okay, it's right.
With Mark.
How'd you get
Okay, yeah, so what it is you're going to use this identity, right? And to do a difference of squares, to make this work out, I'm going to have to write this as, I can rewrite this as 46 plus 8 times 46 minus 8. Right? Okay, and how did I figure out what that was? What I did is we took the difference here. The difference between these two is 16, right?
Yeah.
And half of that difference is 8.
So we just take the half of that.
Yeah, so we can rewrite this 54 as 46 plus 8 and the 38 as 46 minus 8. So we've engineered this to be a difference of squares so as to be able to use this identity and solve the problem.
Okay, thank you.
So go ahead and work out number 21 similarly. I think your x should be 63, right? For number 21. So I'm going to go ahead and leave room for our volunteers.
168 by 63.
58.
Y equals 5.
I like that we have.
What are you doing?
Negative.
And they're really kind of going through 20 was sort of fresh. When I did the video for this, I think I did problem 21 in the video, any of those. I'm going to leave room here.
Plus. So x equals 63.
Yeah.
Hold up.
I'm getting x equals 63.
Yes.
120 times 3.
120 times 3 is about
300.
Never mind.
Is it? Don't lie. 360.
That's what I was gonna say. Then you said
360. 360.
Well, right now, I changed it.
I got
I think it's gonna be fun. I got one.
I think it's a period. I know what it is. I know it's fine. 360.
Chloe, did you watch the class video yesterday?
A little bit of it,
A
yeah.
little bit, yeah. No, I think it was 8th period that went up yesterday.
Did you watch it, Chloe?
No, she
So
didn't.
she watched some of it.
Did she?
You watched
I
all of it?
did, did you?
No, she didn't.
And when Cheyenne was gone, she watched all the videos, she comes back, hands me the work all completed.
Not,
Right?
I'm all like, man, this is the way it's,
Right?
and so,
she was out partying.
and so that's good, so that's what
I
I,
did, because I even got some of his jokes in there.
yeah, he did. She did, yeah.
Jose.
Jose, the Jose joke.
Yeah, see, when I come back, I automatically got a star, I didn't even do any time.
Mm-hmm.
No, it's just because what it is, she's using the system as it was designed to be used, right?
Right, it's very
Okay.
helpful.
Very good.
With you.
Okay, let's go ahead and
No, I'm not done.
let's see what we have
I
here.
can't get that. I'm like,
At least one.
Braden and Lexi, Braden, Lexi, Braden, Lexi, Braden, Lexi, Braden.
Yay, Brayden. Yes, I'm ready.
And Braden was asked, coincidentally, he was asking the questions about it too. Okay, Braden, you ready to go?
BC.
I'm not done yet.
He's, in the car.
He was asking the questions about it though.
This hurts.
Come on, Braden, I wasn't done.
That hurts.
Let me tell you what I've got so far.
Yeah, tell me what you have so far.
X is 63, and I'm done. And Y is 5.
What's the answer, Mark? 3,000 how much is it? $3 grand.
So, I got
It's already in
3
there.
squared minus 5 squared. I'm gonna see something else. Oh, that. So you're gonna do all that? Okay. Tell me when you're ready for me.
So right here you got
60 squared plus 2
plus 2.
times 60 times 3.
What? How was it? Oh, what?
How about? Oh, I see what you're saying. Let's go ahead and write it. I want to get everything written out right.
Why is it plus 2?
Damn, man,
Yeah, yeah. I don't know. Let's go ahead and write this out. So we have. So what we're going to have is this is going to be equal to 63 squared minus 5 squared. Is that right?
Yeah.
Okay. And now, Braden, you're going to break down the 63 squared to
60 squared
60 squared plus 2
times 60
times 60 times 3
What? 60 plus,
times 3.
plus 3 squared
Minus 5 squared.
minus 5 squared. So now we work this all out, you get
3,600 plus 360
plus,
9 minus 25. And then I got 3944.
equals 3944.
Good job, Brayden.
Okay, then we take 58 times 68, hope that's it. Yep, exactly right. Okay, good, thank you, Braden. Okay, and the last one we have in this set is problem 22. So just look at that. You have 2 different students, and one did it correctly, one did it incorrectly.
They did it.
And so what I'm going to do is I'm going to choose somebody to give us an answer for 22 here in half a minute.
I bet.
This one should be pretty easy. Oh, let me go ahead.
Don't put those back.
Go ahead. Okay, we'll break it here. There we go. Great.
You want to do this thing?
Yeah,
No, you don't.
you got it wrong, but for him.
No, he didn't. It's, A did it right, so B did it wrong. Yeah,
What's your name?
B did it wrong.
No, they did it wrong.
No, man.
Okay,
No C.
all right.
How's it?
So let's go ahead and get another volunteer
He's weird.
for this one.
Come on.
Is it not?
At least one.
Yeah, Lee, all right.
That we fall.
That lollipop.
All right, Atlee, what do you think?
I think A is incorrect.
A is incorrect.
That is because after the second line, it says a squared. It says 1a squared b to the power of 0, and I think it should be squared.
Oh, right here?
Yes.
What are you talking about?
So you're saying this A is not right, but B is?
Yeah.
Okay, let's go back and look at this. Atlee, I want you to look at something here.
This moment of silence.
How would you think?
Atlee, I want you to look at this thing right here.
Yeah.
Yup, looking at it. Looking at it. Will we take your decision?
Look at the last line.
What? I think A is correct. Can you go back again?
And Atlee, here, I want you to look at something else too. I want you to look at these problems right here.
Okay. Let me observe.
She's observing.
Observe.
Because it's like,
Oh.
Okay. Okay. I think.
Oh, there.
Well, I know that B is wrong now
Okay.
because the equation is set up
Could be squared.
as B is. That's what I said.
How are you doing that?
Yeah. Yeah, so this is the wrong one here. This is the right one. So
Yeah, that's what
anyway,
Andy said.
that's the idea. What everybody doing?
At least fit.
All right.
At least.
Yup.
All right. What we're going to do with the remainder of class
Party.
is we're going to be working on factoring.
Let's sing a song first.
Oh, you want a song too?
Yeah, we want a song. You want to pick this up?
Yeah.
Yeah, I'm going. Yeah, Siggy will pick it up here. Here.
Pick it up, please.
I want to sing. Yeah, let's play and sing for song. Oh, no. Do you have a song? I didn't finish that.
Hey, you can play a song
Yeah.
so I can sing.
I finished it last week.
Wow.
What I want to do is,
I need a
you
lotion.
want me to sing
Look.
say 5 minutes?
Look at that. Look at. Ew. Yeah. Thank you for coming. Guess whose jacket this is?
Bartek's?
Hey, my boyfriend? Yes, my
my
brother.
All
When
right.
do I have a boyfriend?
What we're going to do is we're going to work on factoring. Our next section, 7.3, is factoring. So this is sort of like a warm-up to that.
Is it on? Oh, no, it's not on.
You want Brian doing it?
Yes, she does.
Oh, you put it in my shop.
It makes her happy.
Play baseball, Mark.
What we have here is a mixture of different factoring type problems. This will be
Wow, reverse.
Brian, do it again.
I don't know why you want to.
Ah, right.
Lately, I can't talk right.
Like the name, Mark, you like the name? Ready for this one?
What did I say? What's your message?
I'm just scribbling. No, you want my actual signature? Look at that, Mark, look at that.
You cannot tell me that's not fire.
How are you?
So in this mix of problems are
So you do that.
required,
We did when they were online.
different techniques. Yeah, we did some of this while people were taking PSAT, didn't we? Is that what you're talking about?
Oh, yeah.
That's why I like
So these right.
Look, see.
So there are different techniques to be used. And what I'm going to do is list them. I will list the different techniques, and sometimes more than one technique is required. But I'm going to list the techniques here. Okay, first technique is going to be find, and I'll say use
That'd be fun.
the greatest common factor, called GCF.
Oh, cool.
All right?
I already know.
I remember this.
Then the next thing is factor quadratic trinomial.
That's in find L.
No,
Find Angie.
what's the name?
And the last thing
Okay.
is what we worked on just a little bit ago with one of the identities. It's called use difference of squares. And difference of squares is going to be used on a quadratic binomial. So usually quadratic binomial. And you can use it on other things depending on the situation. So I'll just call this usually for a quadratic binomial. And always you should use GCF first. Like when you go on the list of what to do in factoring, use GCF first. And so, do we have a GCF for problem 1?
5. Two.
Whoever said
three.
whoever said 3 was right about that.
It was me.
Where? And what's 72 divided by 3? Isn't that 24?
Yeah, 24. I think.
And so now, you've used technique 1 here, and now you can factor, you hope, this quadratic trinomial. And maybe they're not all factorable. I think this one is.
That's it. Okay.
What do we do?
So what would you do to factor this quadratic trinomial? You don't know? Okay.
Distribute?
No, here, let me show you here.
If you distribute, it's gonna be back to the,
Yeah, it'll be.
Yeah, so what you're doing is working backwards here.
Or in the box method.
Well, there are different ways to do this. One way, and I'm just kind of reading the room here, seems like this might be a good thing to do. So what you have is the upper left you have x squared, and the lower right you have minus 24. And then you know the factors of x squared are x and x, right? So x and x are going to go right here. And now you're looking for two numbers which when multiplied together equal negative 24, but when added together equal negative 5. And so you can create a list of factors for that. You need a list of factors of negative 24. So what are some possible factors of negative 24?
Negative 12 and 2.
Negative,
So negative 12 times 2,
Negative 3 and 8.
negative 2 times 12.
negative 6.
Okay, negative 3 times 8,
Negative 8 times
and negative 8 times 3,
4. Negative 4 times 6.
negative 4 times 6, negative 6 times 4. And then you have also 24 and 1, right? Negative 24 times 1, negative 1 times 24. And what you do is right next to it, you make a list of the sum of factors. So now you add these factors together. So here's your list of factors, here's your sum of factors. And so you can go and add these together. Negative 10, 10, 5, negative 5, 2, negative 2, This one's going to be, was it negative 23 and 23. So now you look at this thing right here. Where does that show up on your sum of factors?
Negative 8.
Negative 8 times 3. So these numbers here, negative 8 and 3, are the two numbers which when multiplied together equal negative 24, yet when added together equal negative 5. And so now we can test, and this is one thing that I like about the box method. The box method is an internal check, because now you have down here in the lower left 3x, the upper right you have negative 8x, and these combined together are equal to negative 5x. So that's your check on the work. So this will be your fully factored form for problem number 1. All right? And does that make sense? How many of you were able to do that mentally without going through all the box business and all that? Really? Brindy? Atlee? Braden? Bryce? Okay. These ones here, when you have this right here, factor quadratic trinomial where x is, like you have 1x squared, that should be a pretty easy one that eventually you should be able to do that pretty much in your head. Now, there are other ones. This one here is going to be one where, what's our greatest common factor here? So 6. So we take out the 6, we get 6x squared minus x minus 1. Now, is this one going to be as easy to factor as was number 1? No, it is not. Because this is an example of where you have a x squared is greater than 1, right? You have more than 1x squared. So for this, if you take the standard form ax squared plus bx plus c, a is equal to 6, b is equal to negative 1, c is equal to negative 1. And so for this, you can set up what we call either the x method or bottoms up. Have we done that in this class?
Do we have?
So we have, if you put up AC here and B down here, so what's AC going to be? A times C.
5. No, times 5?
A times C, here's A,
Negative 6.
here's C, so negative 6. And down here, B is equal to negative 1. So now you're looking for two numbers which when multiplied together equal negative 6, yet when added together equal negative 1.
Hold on, what did you say? What did you say?
Negative 3 times 2?
Yeah, negative 3 times 2.
So negative 3 times 2,
That's a different degree.
Yeah, I agree.
You did.
Yeah, negative 3 times 2.
Okay.
No, maybe like 2 times negative 3.
because these added together are negative 1 and multiplied together equal negative 6, right?
Oh, I remember this. Yeah.
So now we're going to divide by A, and A in this case is 6. And we simplify.
Yeah.
So what's negative 3 divided by 6?
Negative 1.
Negative 1/2. And 2 divided by 6 is,
Negative 1/3.
how about positive 1/3?
I mean, positive.
Come on, bro.
So now we take this x minus 1/2 and this x plus 1/3, and now is where we use the bottoms up. So we take this 2 is the bottom that goes up here at this x, so we have 2x minus 1, and then we bottoms up this other guy here, and we have 3x plus 1. And so that's going to be like the partial answer. Then we bring down this 6 also.
Wow.
So now we come down here. So we have a 6 times 2x minus 1 3x plus 1.
That method's easier.
This method here?
Yeah, I like this one better.
Well, the thing that's really good about this one is because you could actually fill out the parentheses here and just sort of estimate back and forth till you get it right. But the good thing about this bottoms-up method, and by the way, you hear it called by two different names. It's either the X method or bottoms-up method, and the whole procedure includes both of those. So it's a matter of what you call it. So you'll hear it called both ways. And so we're going to get, when we get to second semester, we're going to spend a lot more time with this, getting some more preview on this. And so we'll do that. And so, and then this one here, I think this is just the greatest common factor one. So what's your greatest common factor here?
6.
So 6, what else? Any other thing?
5.
X. And what times 6x equals 12x squared?
Wait, what?
2x.
How about 2x? And what times 6x equals 30x
5.
plus 5? So this is going to be our answer for number 3. Yeah, it's pretty easy. So it's greatest common factor, and that's as far as you can get it. So we're kind of, I think what we'll do is we'll just leave it here today. How's that? We'll come back and work on these more tomorrow.
I bet the rest